Hello everyone, welcome to our first lecture. This is an introduction to the Big Data Platforms course. So in this introduction, I will go over some key concept definitions of big data, some key properties, and in addition to the challenges and tools that we have to use in order to overcome these challenges. All right, so when you talk about big data, it refers to when you have huge volumes of data that is generated from different sources. So you have variety here. It can be structured data, unstructured data, uh, which we will discuss later in the lecture. So the challenge here is like, okay, we have this huge amount of data, so where to store that data? And also, once you're able to store it in one place or in multiple places, then when you need the data to make decisions, how to analyze or how to process that data, which has a large volume. So those are the challenges here. Typically in data science, you face like two challenges regarding data. One, when you have few data, so you need to collect more data, or when you have like a high volume of data. So that's the challenge that we're going to tackle in this course. All right, so nowadays we have a lot of data in companies, and even we as individuals, we create a lot of information. So we need to be able to take this data, which initially it's messy sometimes. So we want to perform some analytics, some methods to clean the data, organize our data, get some insights. And the whole purpose of that is that at the end, we can make decisions. We can create some models, in some cases predictive models, in other cases just models to identify some patterns in order to take data to action. That's the whole purpose of the tools that you're going to learn in this class. All right, so let's check like historical context. How were the early days regarding data analysis? So if we talk about like 20, 30 years ago, so pretty much our data in companies was mainly structured data in relational databases. So that refers to tables with columns and rows. So data was not complex, and also it was the volume was limited. So it was possible to store that data in a single computer, in a single storage unit. But then, with the internet boom, so the rise of unstructured data increased not just the volume of the data, it increased also the variety. It's like if you check your smartphone, for example, you have a lot of images, you have videos, sound, text, so you have multiple formats, different data types. So that increases, of course, the complexity of the task. So now we have those two challenges, the volume and the data variety. And now in the digital age, I would say that even everything that we wear, it's creating more data. Your smartphone, but now you also have smartwatch, some of you, or different wearables that are with sensors collecting different data, like the number of steps that you're making in a day, or some of your vital signs. So same thing with companies. If we're talking about agriculture, there are some sensors to track, keep track of the weather, humidity, like critical variables that make that are relevant when you're going to make a decision in that setting. So with the emergence of these technologies, we are facing what we call the 5Ps. I have mentioned two of them. So now we have high volume of data. We have the speed of generation, it's high, so the velocity, that's the second B. We also talk about the variety, so different data types, different multiple sources. And then we have veracity, like how reliable is our data. And the last one, which is really important, it refers to the potential value that we can get from our data. This is the whole purpose of everything. because initially when you're storing, the vast amount of data, and you are, like paying for some infrastructure to be able to process that data in real time sometimes to make decisions. So you want that those decisions are going to have a huge impact in real life. So that's when we talk about the value, how important are the impacts of those decisions. So it's taking the data from raw data to action, to business decisions that will make the difference. So these are the 5 B's that I just discussed. If you check different references, some authors will talk only about the 3 B's. That was many years ago. 3 B's: volume, velocity, and variety. So there is I would say, consensus that those 3 B's are critical. But most recently, they have added the 4th B, veracity, referring to like the uncertainty in your data. It's important. But more recently, in the few years ago, the 5th B was included, which is the value. And as I just said, is the whole purpose of dealing with big data. So to give more, like it's not just like writing codes to manipulate your data, to store it, and to process it. It's like at the end, that's what you get. It's the return that you get from the investment of time and money and resources that you're spending to handle the other 4 B's. Okay, now let's talk about each of those B's. So the volume. So I'm pretty sure that most of you are familiar with megabytes, gigabytes, and terabytes. I would think that's like what we use. So typically a laptop nowadays, we have like, I don't know, the storage of 500 gigabytes, 1 terabyte, that's the standard. But I like this plot. It shows, it's just an estimation. So it shows the amount of data. It's an estimation of the amount of data worldwide. So it says that it's somewhere between 120 and 175 zettabytes. Zettabytes. So that's the amount of data in the whole world. Now, how big is that? So imagine that you give a laptop to every single person on Earth with 1 terabyte, right? That won't be enough to store the 175 zettabytes. It won't be enough. So it's a huge amount of data that we're dealing right now. And of course, you know that it's going to keep increasing. And we face the same problem even with our devices. Right now, when I was recording this video, I had problems with my storage. And I'm sure that you have the same thing with your cell phones. Okay, in the case of the variety, so as I mentioned before, traditional databases is structured data, tables. So if you talk about Excel or relational databases that you can kind of like get or organize that information using SQL. So that's traditional databases. So this type of information is easy to handle. But when you have unstructured data, such as text, emails, social media, images, videos, audio files, that's way more complex. It's not just the storing part, it's the processing part. Even when you're creating models, it's more difficult. I mean, it's way easier to work with numerical data, numerical variables, and even categorical values than working with text. It's important to be aware of this variety because in the past, remember when I showed you the historical context, like companies, and even we as professionals, I'm pretty sure if I ask you, show me your notes when you were taking the statistics course during your undergrad, I'm pretty sure that you will show me mainly how to handle numerical variables, like to find the mean, like a regression analysis, always with numerical variables, maybe some categorical variables. But I wanted to think about your real life, like when you're going to make a decision. Let's say that you're going to buy a laptop or you're going to buy a cell phone. So when you're going to buy, like any other product. So what you typically do is you go online and you start watching videos, like a review of how good is the cell phone or the laptop, or even you will check the reviews from other customers. So what you're doing right there is you're checking images, videos, text. So you're consuming different data types to make a decision. Of course, there are numerical variables such as the price, which is really important, but you're combining multiple sources of information and different data types to make a decision. So that's variety right there. So companies, they want to do the same. It's not just about numerical variables and categorical variables. They want to include now text and other unstructured data. So that reminds me that companies right now, they are fully aware, they want to know like what their customers are saying online, like the reviews, if the reviews are good or bad, so they can improve the experience. Semi-structured data, it's similar to structured data, but in some cases there are some data formats that keep like a standard. For example, an email, even though the text can change, but the format of the email, it's similar. You know, you will know who's sent you the email and things like that. So you can use that structures on how to organize. It's not same as the structured data, but again, it's not like totally unstructured. So that's what is considered semi-structured data. So there are some examples like JSON files, XML, among others. Okay, so the third B, it's velocity. So it refers to the rate or the speed at which we're generating data nowadays. And as I'm like showing this video, as you're watching this video, I'm pretty sure that you're generating data. Maybe you are texting with someone else, or you are taking pictures. So or if you have sensors, so you are creating data like every single minute or second. So if we check, for example, on Twitter or X, in 1 minute or 60 seconds, they create, or the users create around 100,000 tweets, which is a lot. So what we'll see is like that's a trend. It's increasing the rate at which we are creating data, and that's a huge challenge, because if you wanna make decisions with the data, you have to be able to get that data in real time. You should be able to process it right away to make a decision. So in the past, for example, let's talk about Walmart and Target. So typically they, you know, like with the customers' information, the transactions, they were able to analyze like, okay, which product this person is buying, and then after many weeks or even a month, at the end, they will send to those customers, you know, some coupons. But nowadays, it has to be faster. So I'm pretty sure that you have experienced something like this. You're talking with a friend or with a family member about something, and then right away, boom, in your social media, you get an ad, you know, like suggest, oh, you should buy this product that you were just talking about with someone else. So that's what I'm talking about. They capture the information right away, and then there is a model that is predicting that you will buy faster if you get that ad real quick. So that's the idea of velocity. It's not just that we're creating the data real fast. It also refers like that you need to process it in real time in order to be able to capitalize that information. The veracity, it's the quality and accuracy of the data. So it's important to know that the data that we're using is relevant, it doesn't have problems. So we need to check that. So that's when we analyze the veracity of our data. So typically you will see like if there is noise, the variability, that's normal. In real life you will see variability always in different variables. At the same time there will be some errors, you know, like software bugs. It's possible that there is also fraud, you know, falsification. There are problems that is going to affect, of course, the data and the decisions that you can make. Maybe there are some human errors, or maybe something is not working properly, like a sensor, like a faulty sensor. Maybe it's giving you bad readings about something. So these are possibilities, you know, that affect and corrupt your data. You want to check anomaly detection. So it's important to see that, because outliers, you don't want that those outliers are going to affect your analysis. So it's important to check for them. Duplication of data is also another possibility. Out of date or obsolete data. If you have like multiple years of information, maybe data from 10 years ago is not relevant anymore. So it's important to know that. And the fifth B is the value. The value, it's again going from raw data to actionable insights. So that's what we call going from data to action. That's the whole purpose. So it's not, I know that you enjoy the coding part, it's fun, I know, you know, to create all the infrastructure to be able to analyze big data. But at the end, this is what matters. So this is what's going to measure our success, right? If like the whole process had an impact or not. So we go from the problem definition, we start with our data exploration, EDA, exploratory data analysis, where we make some hypotheses. Then we can go with an in-depth analysis, apply maybe some models, like some regression, classification models, clustering analysis, time series analysis, depending on the situation. We get some insights, and then of course we plan or we propose some strategies so we can get actionable insights. Let me show you 3 examples of going from data to action. So the first one is customer churn. So this is when for a company, imagine like a cell phone company, it's like when a customer goes to the competitor, right? So you don't want that, you want to minimize that. Okay, so in this specific analysis, they use for data, they use customer ID, customer information, purchase dates, product IDs, and support ticket numbers. And with that data, so they prepared the data, so they found some like descriptive metrics such as the days since last purchase, total purchases, average purchase value. So those are some important metrics relevant to the customer churn. Then in the EDA, in the exploratory data analysis, they visualize the purchase frequency versus the churn rate. So we expect that as the frequency increases, the churn rate is going to increase. That's what you expect, right? Then with an in-depth analysis, here they use a classification analysis, a classification model to analyze what are the critical variables influencing churn. So finally here, the actionable insight that they found in this case is that customers who haven't made a purchase in 60 days, 2 months, are 3 times more likely to churn, which makes sense. I mean, if they don't buy a single product in 2 months, so you should be worried. Therefore, if something like that happened, then the solution for them is okay. So implement a re-engagement campaign at the 40-day mark. So after 40-day mark, after 40 days, 45 days without a purchase from that specific customer, they will kind of like maybe offer a discount or call that customer and avoid that customer to churn. Okay, so that's example number 1. Let's see example number 2. Product performance. This is to analyze like how good you're selling one product or which products are having problems, are struggling in the sales process. Okay, so the raw data here is product SKUs, daily sales, and customer ratings. Data preparation, so these are the descriptive metrics. So aggregate sales by week, average rating per product, so that will give you an idea of the volume of sales and the acceptance in the market. The EDA, so here is to plot the sales trends and identify top and bottom performers, which products are doing really good and which products are having problems. In-depth analysis here was to a correlation analysis between the product features and sales performance. So to check like which product features like were successful or were kind of like having an influence in the sales performance. At the end, the actionable insight in the second case is that products with customizable features outsell standard models by 40%. That's what they found in their data. So the strategy was to prioritize development of customization options for upcoming product lines to ensure that you have higher sales. So that was what they got from data. Number 3, marketing campaign effectiveness. So the raw data here that was used was the campaign dates, ad spend, click-through rates, and conversion rates. So click-through rates is like the clicks, number of clicks, and conversion rates maybe the number of people that's gonna buy the whatever was offered, the service or the product that was offered. Data preparation, say it's so they calculated the rate of investment for each campaign, and second by channel. The EDA, so they compare campaign performance across different channels. In-depth analysis, multivariate testing of ad elements to see like the impact of visuals, for example, in the effectiveness of the campaign. And the actionable insight is that they found that email campaigns with personalized subject lines increase open rates by 25%. Therefore, they decided to implement personalization across all email marketing efforts. So the other day I was reading a book where they mentioned a similar example. It was for Yahoo. For Yahoo, you know, they have like the engine search, but also they have like email services, right? And they also have like Yahoo News, it's a website where you can, you know, like read the news. So at some point they realized, just looking at the data, that when people are reading the email, they are more likely to read the news. Therefore, they made a decision at that moment to, when you were checking the email, you were able they were able to add like a small bar where you see like the headlines of the news. So just by doing that, they increase the number of visits to the news site by more than 50%, almost 70%. So they didn't know why, but just by looking at the data, they found a strong correlation. They made a decision, they take data from action, and it was effective. All right. So what are the challenges of large data sets? We have seen some of them. So we have an unprecedented data growth volume. So we have massive scale, we have complexity and diversity, and the traditional methods fall short. So there are some limitations in the traditional databases. So we need special techniques to be able to cope with the challenges. So we need advanced technologies for big data processing. So here, some of them are distributed computing, and we will see them in the next slide too. NoSQL databases and real-time analytics. So the idea is that the applications, we want to make an impact. So we want to transform industries with the big data, and the idea is to drive innovation while we're doing that. So you have to learn some of the challenge with the data, and we have mentioned this before, is we have variety, so we have different data types. So typically, we are more prepared to analyze numerical and categorical variables. I'm talking about engineering majors, people in business. Yeah, most of the time you have seen numerical and categorical variables. It's changing. I'm pretty sure that now we are more like getting familiar with text, but most of the tools that you know already are like oriented to numerical and categorical. So we need to learn how to handle text. Time series is numerical, but here I'm using like a different distinction, because in time series there is the order matters. There is a timestamp, which is not relevant maybe in regression, classification, analysis, where you have observations, and it doesn't matter if you mix them. But in time series is relevant, the order is important. Images, of course, videos, and spatial data. So there are different data types that increase the variety in our data. Well, we have mentioned already the structured data, but just to be more specific, so remember that structured data refers to data that is organized in a predefined manner. So we have tables with columns and rows. So an Excel file, or if you're using a database like Oracle, if you're using SQL in general, so we're talking about structured data. And unstructured data, it's more like text data, images, videos, but also we have like web data, such as web pages and logs like all the information, like when a user like clicks, clicks in a specific button and things like the time it takes for the visitor to read something. So that information it's critical also in the decision making. So sensor data. So the Internet of Things, those devices are collecting data. Like in some cases structured, but in others it's unstructured data. So the applications of structured data are really big. So some of them, just to mention some nice applications. I'm pretty sure that you have seen a customer sentiment analysis. So sentiment analysis is when you take like a text and you check whether the person that wrote that text was happy, angry, or it was neutral. So that's the sentiment analysis. So companies like to do that on social media. They check, let's say X, what used to be Twitter, and they start like kind of like gathering the tweets that where the users tag the company, so they can understand, like what was the mood of the review of the customers, and also the reviews. If we're talking about Amazon, for example, so you can perform some sentiment analysis to see like what they were saying. There is also like a topic modeling, not just the sentiment, also topic modeling. So topic modeling, it's like a cluster analysis. So it's to find like, okay, we are talking about me, but I want to know about what, like what aspects. So that's the topic modeling. In healthcare and medical research, images are important here. So it's increasing, like the number of research and applications in we're using images and different lab results. The doctors are able to predict whether a patient has a specific disease or not. Natural language processing is getting bigger with artificial intelligence, with the generative artificial intelligence such as ChatGPT. Kind of like the whole world opened their eyes, like everyone, kids from school and all the way to people working in the industry. So everyone in society realized that this is useful, like I can use this. I'm pretty sure that you are more productive nowadays because you're using these tools, like whether when you're coding or even when you're writing an email or you're doing different activities. I'm pretty sure most of you are using these technologies, ChatGPT, Gemini, or others. So yeah, those are applications of unstructured data. Market research, when you're analyzing what the customers are saying, same thing, same idea. Okay, so how's today's world? So in today's world, the 5Bs are a reality. So we have to cope with the 5Bs. We need the tools to be able to handle this big data, which is going to keep increasing. It's going to keep increasing. And you know that data is a strategic asset. So if you want to make good decisions, then they have to be data-driven decisions. And that's critical. In order to do so, we need to know how to store the data, how to analyze the data, how to process it, and it has to be fast. So in the future, data is going to continue growing in complexity, in volume, and in all the bits. And we're going to keep using artificial intelligence, machine learning tools in order to perform analytics. And that's what you're going to learn in this course, how to do that. So some of the key concepts and technologies that we will cover during these 15-16 weeks: this distributed computing, NoSQL databases, data warehousing, data lakes, stream processing, machine learning, and AI in this context, in big data context, cloud computing, Hadoop and Spark, of course. We will go over the frameworks. This is an example of big data. So the idea is that you imagine that you have a production line for a company, and let's focus in one machine. It's really important. It's a really important machine. So what are our data sources? We have sensor data from the machine. So that includes the maintenance logs, historical failure data, and other relevant variables. So the technology that we can use is data lake. So we can store raw sensor data and maintenance records using Hadoop. You will learn this. Stream processing, so the idea is to process in real time sensor data for immediate anomaly detection. It's not just storing the data, you also need to analyze the data, you need some models to be able to find if something is changing in the performance of the machine in real time. Machine learning, so we need to create some predictive models to be able to forecast when the equipment is going to fail. That's for preventive maintenance. Cloud computing is relevant here if we want to deploy the models in our web services such as Amazon Web Services or Azure. So yeah, we need to, there are some key concepts to be able to do that. And the outcome of these applications, so the manufacturing company can predict equipment failures before they occur, reducing downtime, optimizing the maintenance schedules, and of course, saving costs. Okay, so the conclusions of our first lecture, this is a famous phrase, I'm pretty sure you have heard it before. Data is the new oil. This was said by Clive Humby, a mathematician. So, same thing as oil. Oil by itself, you cannot do like something useful just with the oil. I mean, you take the barrel of oil, and it's useless unless you transform it into something else. Same thing with data. You might have, like tons of data, but if you don't know how to transform, process that data, it's not gonna make a difference. So it's important to be aware of that. The 5 B's of big data are a reality. So we need to learn the tools to be able to cope with these B's. So it's important to know how to use the technologies to handle big data. That's what you're going to learn here. And never forget that it's not just about coding. It's important, it's nice, I'm pretty sure that that's one of your main motivations. But at the end, what really matters is like going from data to action. That's the one of the lessons that I want you to remember throughout the whole course. So I know the coding is fun, but actually, if you know that what we're seeing right now is like the tools that we have available, the coding part, it's kind of like way more easier now than it used to be 10 years ago. With generative AI, we are more productive when we're coding, and we can get some with a couple of prompts, we will get what we need. So what really matters at the end, guys, is that what is the purpose of the whole analysis? What is the business questions that you want to answer, right? So with those insights, is when you're going to make a difference. Okay, so that's everything for our first lecture. I'll see you in the next video.